Hello everyone, this video is being made to meet the project submission guidelines given by PRITHVI Organization. The name of my project was Human Activity Recognition. This project helps in determining the activity of a user. This project analyzes a data and then decides the activity of a user. I was provided with two different data sets that were training dataset and testing dataset. Training dataset was used to build this project and testing dataset was see whether the project is working fine or not. The data was recorded using two devices that were a smartphone and a smartwatch. The smartphone was running on Android 6.0 and the smartwatch was running on Android Wear 1.5. Total 34 different users were analyzed and 18 different activities were checked and recorded, and the data was created finally. Also, all the activities were assigned with some variable to keep it simple. For example, walking was assigned with variable A, sitting was assigned with variable B, etc. This information was provided by the organization in their mail. They attached a PDF, and in that PDF the information about all the activities and their corresponding variable was given. All the data was recorded at 50 Hz, that is every 50 milliseconds. Now in the first cell I have imported TensorFlow and then sequential, flatten, dense, dropout, batch normalization, con 2D, maxpool 2D and atom. The version of TensorFlow is this one. You have to install this TensorFlow to make this project. Now all these things will help in creating model that we will see ahead. The models that we will see ahead are CNN model, learning curve and confusion matrix. Then I have imported pandas and numpy to work with lists and arrays, and then I have imported matplotlib to make graphs. I also imported sklearn to use train test split. This train test split is used to separate testing data from training data, but I was already provided with training data and testing data separately, so this was of no use for me. Now in the next cell I have called an empty list and named it as process list. Now first we are processing the training data to make this project, and then afterwards we will process testing data, but first we are processing the phone acceleration data. Now in this we have called a loop from range 1 to 21, so this will read all the 20 files one by one, and all these information will be appended in this empty list. We also have to remove all the commas and semicolons in the data. I will show you one example of the data. Now here the user is 1620 and the activity is A. This can be sitting, walking, etc. You have to see that PDF to know which activity was assigned with the variable A. And this is timestamp, and this is X, Y and Z value. Now you can see that the data is separated by commas and is ending with a semicolon, so we have to remove all this before appending it in the list. Now after processing the phone accelerometer data, we have to see phone gyroscope data. The same process will be carried out, but we have to make sure that the name of the file is correct. Here we have to access this directory, but in this we have to access the gyro directory. So make sure that you access the correct directory before analyzing the data and appending it in the list, because it will generate an error if you commit a mistake. Now same goes for the watch data. Now watch accelerometer data is being analyzed now. Every file will be read, each and every file will be read, and all the data will be appended in the list. Same goes for watch gyro data. And then we have to create columns named user, activity, time, x, y, and z, and we have to create a data frame, and in that data frame processed data will be processed list, which was the name of the list that we were appending the data in, and the name of the columns will be columns. These will be the columns for the data frame. Now after running the data, we get the following data frame. Now in this, all the training data is recorded in this data frame. Now all the data is stored in process list. All the training data is stored in process list. This will help us in creating this project. And now using that process list, we have created a data frame named data. In this data frame, we have 6 columns and 5575010 rows. This is a very huge data. That's why running all the kernels is taking a lot of time. Now by running dot shape, we can see the shape of the data frame, and by running dot info, we can see the info of the data frame. All the values are in object type. We have to convert x, y, and z into float type to make graphs and working further. We also have to check whether there is a null value or not, but since we are having no null values, so we are quite lucky with the data that is provided to us. This is the total number of value counts of each and every activity. Now here we are converting the xyz from object type into float type. After running this cell, xyz will be converted from float type to object type. Also we have to keep the fs value as 20 because the data was recorded at 20 Hz, that is every 50 milliseconds. And then we have created a list of activities that were analyzed. All these activities are assigned with some variable, that is p, m, k, and all. And then we have plotted all the activity and all the data into a graph. Now you can see for p activity the following is the graph. Similarly for m activity, the graph is as follows, and this goes for all the activities. Now after making the graph, we have to drop user and time column, because the models that we will make ahead will have no use of these two columns, so we have to drop the user column and time column. So after dropping these two columns from the data frame, we have a new data frame named df, and now in this df data frame we have activity x, y, and z column. Now we have to balance this data, because this is unbalanced data, as each and every activity has different value count. So to obtain more accuracy from the project, we have to keep the value count same for each and every activity. So we have to check which activity is having the least number of value count. So activity B is having the least number of value count. So now this number will be assigned to each and every activity. Now by running this cell, we can convert all the values into 289076, that is the least number of value counts given by an activity. Now all the balanced data will be stored in balanced data frame, and now by calling this balanced data, we are having this data frame now, and this data frame is balanced because each and every activity is giving the same number of value count. So now accuracy will be more. As you can see, each and every activity has now 289076 as value count. Also we have to import sklearn and to use label encoder. This label encoder will help us to assign some value to the activity, because activity is in the form of string. So in making model, we have this will cause a lot of problems, so we have to assign some value to this, to the activity. So by calling this, we are adding one more column, that is label column, and now this each and every activity will have a unique label value. And now if we call label.classes, we have an array where all the activities are listed in the form of object type, and all these classes will have a label value from 1 to 14. Now the data that was analyzed, that was processed, has to be in standardized form. So we have to create a standardized data so that each and every value has same variance. So now we have taken new variables x and y, and we have called standard scalar. This will help us in generating the data that has same variance. And now by calling this cell, we have a data frame, and in this data frame all the data have same variance. Name for the standardized data. This can be done by importing scipy stats as stats. We have to set fs as 20, frame size as fs star 4, and hop size as fs star 2. Fs is set as 20 because the data was recorded at 20 Hz, that is every 50 milliseconds. Now we have to create a function getFrames. We have to pass df dataset, frame size, and hop size. And now by calling all these statements, we will create this frame. And now by finally calling this function in this cell, we have created two frames that are x and y. And by calling dot shape, we can see the shape of these two frames. Now after getting the frame from the standardized data of training dataset, we have to process testing dataset. Now all the process that we have just done above will be carried out for the testing data too. Now in this, we have to take a new empty test process list, and similarly all the processes will be carried out. Now by moving down, we can see all the data frames, all the graphs for all the activities. We have to keep in mind that all these processes are for now testing dataset. This will check whether this dataset will check whether our project is giving good accuracy or not. Now you can see all these data frames and all these value counts. And then going down, we have now in this also we have to create the frame from the standardized data. And now after creating the frame, we can see the shape of the test frame. This frame is testing data frame, and this is the training data frame. Now we have to make the CNN model, which will be created by calling all these statements. This is a generalized statement. These all are generalized statements. I have copied it from Stack Overflow, and by passing all the values that I have just obtained from calling all the processes, we have to pass all those values in these statements to make CNN model. And after this, we have to compile the model, and in history we have to fit the model by passing x frame and y frame and setting verbose at 1, and validation data is x test frame and y test frame. And after running this cell, we get the following output. Now as you can see, we have an validate accuracy of 32%, 33%, 32%. Now this is near about 32 and 33, and this is satisfying the criteria that was given by the organization, that is the accuracy should be above 30%. If it would have been below 30%, then I would have been awarded 0 marks. But since it is above 30 marks, above 30%, we will see what organization will analyze about it. Now to plot the learning curve, we have to pass history and epochs. Epochs will be the number of rounds that it has gone to obtain the accuracy, and history is obtained from the cell above. And now passing these values in this function, we get this learning curve. Now the training graph is here and the validating graph is here. So we can see that training graph has much more accuracy than the validating test data. So I am still working why there is such a drop, but still the accuracy is above 30%. It is satisfying the criteria, but there is a accuracy drop, so I am still checking on it. And finally we are creating confusion matrix by passing these values. And this is how this project was created. I hope you guys liked these videos. Thank you.